2,000 years later.
Yeah, okay. What's up, gangsters? Here we are in the present after a little bit of time travel. And yeah, so this whole brough superior thing has turned into kind of a mess. Yeah, that is, to be more clear, the Model Factory Hero Brough Superior SS100 project that I started exactly 7 years ago. Yes, 2018, because it is now October of 2025. And I was so emotionally scarred by working on that project the first time around that I put it away on the shelf of doom for 7 years. And I was working on some other stuff earlier this year, and I kept thinking, I really need to just knock that thing out. I need to just finish it. I need to just go grab it off the shelf, and I'll just bust that out. It'll just take me a couple of months. Yes, that was like 3 months ago, and here is where it is. And I've recorded a bunch of content, and finally am getting around to turning that content into videos. So parts 1 through 4, which are from the way back, are here on my channel. And I'm now about to do this, part 5, and a part 6, and a part 7, to get caught up with this ridiculous build diary. I mean, it is excruciating. I actually had to go back and watch what I said back then, and it's hilarious how optimistic and full of, hope and all the possibilities I was when I started the kit. And you can tell even by the end of episode 4 that I'm kind of beat down. Yeah, and I apparently had, purged all of the trauma and forgotten just how bad it was because I was, as I said, optimistic that I was going to just knock it out. And yeah, that has not happened. It has been a full-on wrestling match, and I'm going to detail it here in excruciating detail. And the thing is, why does it even fucking matter? Because you can't even get one of these stupid kits anymore. I don't know if they'll ever do another production run of them or not, but last I checked a few months ago, they show on the Model Factory Hero website, but as not available. And yeah, I don't know. Who knows? So there might be 2 people who will actually be interested in this, but it's just a thing. I feel like I gotta finish it out. I gotta do it. Yeah, so, right. Anyway, with that, let's get into what's happening now. So I decided to start at step 1, which I did not do before. That's all basically building the engine and getting it installed in the frame. We'll come back to that in a second. I started back when I was working on this with the wheels and remembering how difficult they were and how unsatisfied I was with the results because they just weren't super straight. I'm glad that I did because I'm not sure I'd have the motivation for them now. They are what they are. And hopefully they'll be fine when they're actually installed. But it's kind of interesting to look at them now. However many years later, I don't know, 5 years later, damn. All of this super glue has turned oddly yellow. And some of these are not still stuck where they were supposed to be. Anyway, I'm not going to worry about that right now. It's all about the engine. And the first thing that I needed to do was set up my little poor man's drill press with my Proxxon ep394 micromote, which, it works okay. This fixture that I got from Proxxon is, a little bit janky. It's a hassle because with this quick connect chuck that's very convenient for changing bits, normally it's a hassle in this setup because I have to take it out to change the bits rather than just being able to do it with a regular chuck. So that's kind of annoying. But with the speed control that's over there, yeah, can't really see it because of the arm of the camera. Anyway, yeah, over there, I can get it to where it spins, down around 250 RPM if I want to, and the foot control, or the foot switch rather, because that's all it is a switch, makes it, really easy to hold on to things and position them where I need to in order to drill holes. And there are plenty of holes that need to be drilled in these engine casings. And because they all start out looking like this, where there's just a little divot. And the divot is really probably enough to where you can get the hole in the right place without using a drill press. But the drill press obviously makes things a little easier, a little faster, and I have a little more confidence that the hole is going to be straight and all the things. Anyway, let's talk about those holes. So those are for all of these screws, or screw, facsimiles. They're not actual screws, that are M131, and those are these. They're all, one good thing is that they're all pretty much the same. And so that's nice, because once you know what size hole to drill, it's pretty, it's good. You can just get them all done with the same size bit, which is great if it's hard to change said bit. But, okay. They don't really do a good job in the instructions of telling you what size those are. They nominally measure 0.9 millimeters, but because of flash and not being really perfectly round, it ends up taking a 1.1 millimeter bit. Or as I'll show you in a second, what did I use? I used a number 59. I think that's right. I think that's what I used. Anyway, so that's pretty good. Makes it pretty easy to get them all right. But that's not all that's got to happen here. As you can see, so this is a bit confusing. So right here you can see they want you to attach the two halves of the engine casing together with this black screw. Now, if you know how to read a mechanical drawing, you know that what that says there is drill a 1.4 millimeter hole by 3 millimeters deep. That circle with the slash through it, that's the diameter symbol for a hole. But that's a little bit confusing because what size is the screw? And, you know, I mean, logically, you'd conclude that you need to drill and tap part M12, right? In order for said black screw to screw into it, right? Well, so then you start looking at the screws, and again, they're all pretty consistent. And you get out your digital calipers and you measure them, and you see that they are actually 1.37 millimeters, which, as it turns out, is what that's about the diameter of an M1.4. So you're like, well, okay, what is this actually? Well, if you look here on the front, down in the fine print, you can see that it says black screws, okay, and these are Phillips head, come in exactly 2 varieties in this kit. A 1.4, again with the incorrect nomenclature there. And I don't know, maybe it's correct in Japan. I don't know. Anyway, 1.4 by 3 millimeters long. That's an M1.4. So then you can pretty quickly go to the correct chart and learn that a 1.1 is the right tap drill size for those screws. I'm not going to trust my ability I'm not going to trust the screw to self-tap, which might be what some people would think, because in plastic or really soft white metal, that might work. This is not that. I know from experience with the wheels that you really need to tap these, and I've got a nice little set of metric taps. So let's talk for a second about drill bits, okay? So a lot of guys want to use these. Let me get them out of the drawer here. These printed circuit board drills. I see these, because you can get them pretty cheap. There are hobby companies that sell them, and they're nice because they all have a constant shank diameter, and you can get lots of sizes. I mean, there's a 1.1 right there, and they're great. But here's the thing. First of all, these things are super brittle. They will snap off if you just look at them sideways. And so you should never, and I mean never, use them for blind holes, because if you snap one of these off in a blind hole and there's not enough to grab onto to pull the stub out, you're going to be in a world of hurt. Ask me how I know. So I would never use these on blind holes in any material. The second thing about these is, if you look at them, they have a relatively slow helix, all right? See how shallow the angle is on the twist? That's because for printed circuit boards don't so much cut as they do grind. The swarf from a printed circuit board or a phenolic type material is basically dust. And so not only are these used in CNC machines where there's zero chance of side load and they're spinning them incredibly fast, but there's not much chance for them to grab. And grab is exactly what these things do when you try to use them to drill soft material. I use these pretty much only for hand drilling when I'm going to do a through hole in something like plastic or resin. And more often than not, what happens is these things basically end up trying to screw themselves into the hole, and they don't actually drill it out until you get to the shank, and it can't proceed any further, and that's when it actually starts to cut. And that's not what you want, because in a material like this, all right, that's soft enough. I mean, this material, surface hardness is probably, I don't know, maybe close to the same as what a printed circuit board is, but it's a more ductile material, and so the swarf comes off, as it does with most metals, in these spirals, because what you're doing is you're actually cutting the material. And so what'll happen is that a bit with a slow twist like this tries to screw itself into the hole, and as soon as the torque becomes too much, one of two things happens. Either your drill motor stops, or the bit snaps itself right off. And if it's a blind hole, again, you're in bad shape. So don't use printed circuit board drills, honestly, for most things. I rarely get them out. And that's also because I've got a great set of tiny little wire high-speed steel drills. This is a set made by Excel. You can get it on Amazon. I think it's like, I don't know, it's like, maybe it's $30, which might sound like a lot, but trust me, you can practically drill around corners with these things without breaking them off. Because they're high-speed steel, they're tougher, and also when you look at the helix, you can see that the twist is significantly steeper. And so they work much better for soft materials like polystyrene or this white metal alloy that these Model Factory Hero kits are made of. But for bigger than 1 millimeter, I've got this set over here. And it's not metric, but it has such small increments that I can get pretty close. And so even though the number, I think, what was I using? The number 57.043 that I'm using as the tap drill for these M1.4 screws is a little small, not quite 1.1 millimeters. Yeah, it's close enough. It's working fine. The one thing that sucks, though, and I really wish that I had a drilling a tapping fixture, is that doing it with this handle and the way that this thing, fits in there, it's just kind of janky, especially if you got stupid lobster hands like I do. So that's not a lot of fun, but you can get it done. So that's that. Once I get that done, though, and I go to screw them together, I'm going to be facing my next challenge. And that is that these parts are very much not flat. This side, not too bad. The other side, definitely not flat. And I'm gonna have to work that out. Maybe with, I don't know what I'm gonna do. I haven't really decided yet. Again, this is very clumsy and not easy to show here, but oh yeah, you can see it. Yeah, very not flat. Okay, I know this is going to outrage some of the Model Factory Hero loyalists out there, but this is the sort of thing that causes people to say that these kits are rough. And honestly, anybody who denies that is either delusional or just trying to feel better about how much money they spent on one. So I'm just carrying on with the drilling and tapping, and there is a lot of it. And you really got to do all of it kind of up front. And even though some of it would certainly be made easier with a tapping frame or a tapping fixture, whatever you want to call it, sometimes you just got to do it freehand, like this situation right here, where we got to tap the ends of these frame spars, And yeah, you can see that one is very much off center. They give you a little bit of a divot right there to try and, help you drill it in the middle, but obviously it didn't help me out a whole lot. Anyway, when you're freehand tapping, these things are clumsy. Even when your hands work good, they're just clumsy. This is really designed to be used in a tapping frame, or when you have the workpiece, clamped like this. So, yep, just whipped up a little tap spinner in Fusion 360 and knocked it out in about an hour on my little Mars 4 Ultra 3D printer. Didn't even bother to cure it. This gives me a little bit of a helper, and once I get the tap started, then it's a lot easier to just spin it. It's still hard to hold them straight, but you just gotta be careful. Now, for a blind hole like this, you need one of two things. You either need a hole that is quite a bit deeper than you're going to tap it, which is not a big deal on something like this, or you need a blind tap. So the difference is, this is what a through tap looks like. It's got that guide point on the end of it, and if you've got an extra, it's pretty easy to convert that to a blind tap by just grinding off the tip of it. That's how we do it on the farm. So the next thing is going to be to get this lower frame cradle fitted on here. As you can see, I got the engine cases fitted in there with their screws, and this is next, and it's about ready. And this is a good example of why Model Factory Hero kits are kind of rough, or at least require a lot of work. You see that right there? That is where that pin right there is going to go, and you can see there's a lot more pin than there is hole. So, yeah. I know it enrages some of the fanboys when you say a Model Factory Hero kit is rough, but hey, they are. It is what it is. Okay, this just gets kind of comical, and I can't resist sharing. So, super easy to clean that out with an 86 thousandths drill bit, because the pin is just slightly over 2 millimeters, and that's what I picked. I wanted to give it plenty of breathing space, so that's good. So now the pin, there's an equal amount of pin and hole. Yeah, but not so fast, champ, because hopefully I can get this positioned where you can see it. Yeah. Okay, it's resting pretty much where it's supposed to be on the back end there over to the left. The pin is all the way in, but look how far we are on the front from the bottom of the front frame spar. And that cradle is straight, so if I force it, it won't be straight anymore. So, yeah, what to do. Now you got to make a choice. Do you add material to the bottom of the frame spar, or, I think the easy answer is going to be to subtract some material from that boss right there, probably quite a bit, and probably subtract some material from that pin as well. Yeah, so yesterday, after I talked about how I was going to get this thing to fit properly, it turned into a train wreck. So I removed some material from this boss and deepened the hole and shortened the little pin right there, and got at least part of the problem taken care of, which was to get rid of the distance gap between this end of the frame cradle and the down tube. Still has, yes, a huge mismatch in the locations of the centers, but that's a different problem and not a good one, because as you can see, the dimension is correct on the back part of the cradle, and so I don't really think that this is like a shrinkage issue, because if it were, then this one would be misaligned if you had the center one in the correct place along with the front one. I don't think it's a shrinkage issue. I don't think it's any kind of process related issue. I think it's just a mistake in the design, because the distance between the down tube and the seat tube is pretty fixed by the engine cases. So something's just wrong, and I'm going to have to figure out how to deal with that. Anyway, so as I was studying on the problem, I put the screw in right here to hold this thing in place so that I could, pick it up and look at it and study on it. And I had the screw snugged in there, but as you will see, even with the screw snugged, there is not a lot of threads. Hold on. I'll show you exactly how many. Yeah, I'll be back in half an hour after I find the fucking screw. Okay, yeah, well, fuck that. I'm either gonna look for the screw later or not at all, because given what I'm about to tell you, that screw is probably no longer gonna be needed. So I'll just borrow one of the other ones. I don't know if for the many hundreds of dollars that this kit cost, whether or not they included any extras. But yeah. Anyway, so with the screw all the way in there, you only have that many threads sticking out, which is not a lot, especially given how soft this material is. And of course, while I was studying it, I bumped this piece and it ripped the screw right out of the tapped hole right there. So yeah, that's a fail. And the first thing I have to do is resolve that. And I think what I'm probably gonna do is put a piece of brass tubing in there and end up just pinning it and maybe soldering it. We'll see. Oh, by the way, before I forget, I did show you guys before that the halves of the engine cases were were each warped a little bit, one of them quite a bit more than the other one, and you can see I got that all resolved. And what I did, I mean, yeah, I could have just clamped the shit out of it, but this is white metal, and I knew that it would be pretty easy to flatten it out. So I did something that you rarely get the opportunity to do in scale modeling. I used one of my very flat 1-2-3 blocks and a portable handheld impact device to apply some physics, and flattened it out with a very light tap, and I used a wooden block so I wouldn't mar anything, but that pretty much took care of that. They still were not, the two mating faces were still not perfectly planar though, so I did clamp the shit out of them anyway, and wicked some black super glue into the joint because that also looks kind of like a gasket. Okay, so there you go. That kind of gets up to the point of where I thought I was going to be, what did I say? Shortly ready to apply some paint. And as you can see, I'm not anything like that close to applying some paint. Lots of problems that showed up that have to be solved, and that's part of what's going to be happening in the next 2 episodes. So anyway, if you've somehow suffered through this, look, I really appreciate it. As always, thanks for watching, and much love.